You are in the meeting now.
Recording in progress.
Okay, good morning, ladies and gentlemen. How are y'all doing today? Good? Bad? Terrible? Worst day ever? Best day ever? Yes! Alright, maybe not the best day ever, but you're doing alright. That's good. Um, so, today is going to be very much continuing the theme that we had on Monday, addressing your questions over assignment 6, 7, or any previous assignments. We spent a lot of time on Monday addressing questions over assignment 6. We can continue that, or we can transition into assignment 7. If I sound funny, I'm sucking on a cough drop right now. I did go to the doctor yesterday. He gave me a shot and some medicine that looks like horse pills. Um, and so I really hope to start feeling better soon. So, as I like to say, the floor is yours. I don't have any announcements. Plan to be here on Friday, and we'll continue this, and we'll also have a quiz for week 3 on Friday. All right. How can I be of service to you?
Can you do number 12 on
From
assignment
what?
6?
Assignment 6, number 12. Excuse me. Okay, let's get this set up. Assignment 6, problem number 12, we have x to the 2/3 is equal to 64. So, the idea that we're going to employ here is for x to the a over b, then x to the a over b raised to the b over a. So this is a flip or a reciprocal exponent. It's just going to be x. If x is raised to a power, then by raising it to its reciprocal power, the exponents essentially cancel out. And the reason why is, if we recall our power rule for exponents, when you have an exponent raised to an exponent, you're going to multiply your exponential values, which then you get AB over AB, which is just x to the 1, which is just x. So that's how we're going to get rid of the 2/3. So what I'm going to do is I'm going to raise both sides to the 3/2. So you get x is equal to, now here's another thought that we need to employ. How do we translate 64 to 3/2 into something that we can work with? So again, another thought for us. X to the a over b translates to the following. A in the numerator is the power of x, where b in the denominator is the index of our radical. Another way to write this is the power of a can float in or out of the radical, so you could write this as the b root of x raised to the power of a. Now, I want us to look at this real quickly, because this is something that we have to be paying attention to. If you've watched the notes, there's certain times when you include a plus or minus notation, and there's other times where you don't. So let's see what happens here. In this problem, 3 is the power of 64. And 2 is the index. Now, because 2 is the index, I guess I should write another note down here. The square root of x is equivalent to, we don't write this, whenever you have a radical with an index of 2, we just interpret that as the square root of x. The reason is this is equivalent to x to the 1/2 power. So x to the 1/2 power is equivalent to the square root of x. So, because we're dealing with a square root, so I'm just going to get rid of that 2, I'm going to ignore it. Because we're dealing with the square root, we have to include the plus or minus notation. Anytime your index of your radical ends up being even, we have to include the plus or minus notation. So if this was, say, to the 4/3, then you have 3 over 4. Well, you would include a 4 right there. Because 4 would be even, you include the plus or minus notation. Now, I don't want to do 64 to the 3rd power. Too much work. So, I'm just going to think about the square root of 64 and then raise that to the 3rd power. square root of 64 is 8 to the third. And you have your calculator with you, so you should be able to evaluate 8 to the third. 8 to the third should be 512, so that's why we get plus or minus 512. Alright, so does that make sense? How to tackle problem number 6?
Yeah, whenever I over it, I put different numbers in.
Alright, you are kind of breaking up there, but it sounds like you understand why, what you were getting wrong. So, I'm glad this helps. Excuse me.
So we
Alright,
just
what else?
completely forget about the 2?
Pardon me?
Do we just completely forget about that 2?
Yes, so the 2 right here, is that what you're talking about?
Yes, sir.
So, the reason that we can ignore that 2 is because if you have the radical with an index of 2, it's the exact same thing as just saying square root. So you know how, for example, if I wrote x, we understand that to be 1x. Do we write the 1? No, we don't write the 1. We just, because we understand that x means 1x. It's the same thing for saying if I have x, that's equal to x to the first power. Do we write the 1 every single time? No. Why? Because we don't need to, because we understand that x is x to the first power. It's the same reason why, if I say square root of x, you can rewrite this as the square root of x with an index of 2, but we don't do this because it's redundant. We don't do this process of writing down a 2 every time we take the square root. If you want to further clarify this, well, you may be saying, well, what if there's an index of 1, Mr. Clopton? Isn't there an index of 1 right there? Well, if you had an index of 1, that would mean you had x raised to the 1 over 1, which is just x. So that's just another way of writing x. X could be equal to the square root with an index of 1, but we don't do that. I mean, that's just silly. So, did that clarify why we just ignore the 2?
Yes, sir.
Okay. I need to be a little bit more clear here. There we go. Alright, what else can we look at?
Can we do number 15 on assignment 6?
Yes. Yellow, black. 15. We have x to the 4th minus 5x squared plus 4 is equal to 0. Now, there's a little bit of a clue as to how to solve this problem, because the directions say solve the quadratic type. So we already know that this is a quadratic type equation. And there's a process that we use to solve quadratic type equations. To solve quadratic type equations, we're going to use a substitution technique. we're going to let u be equal to x squared. So I'm picking the variable and its exponent of the middle term, and we're going to let u be equal to x squared. Then u squared is x squared raised to the second power, because what is u squared? U squared is u times itself. So that means we're going to take x squared and we're going to raise it to the second power, and that gives you x to the fourth, which is what we have right up here. So once you establish your substitution, you can replace x to the fourth with u squared. You can replace x squared with u. And now what you have is you have a quadratic equation. Now, these are engineered to be solved rather efficiently. And I'd say an efficient way for solving this would be to factor. Factors of 4 that add up to -5, how about a -1 and a -4? Which then means that u minus 1 is equal to 0, u minus 4 is equal to 0, which then means that u is equal to 1 and u is equal to 4. Now that's great that we just found out what u is, but I want to know what x is, because that's the variable of the original problem. So we're going to recall what does u equal? U equals x squared. So x squared is equal to 1, x squared is equal to 4, and now we're going to go through and solve for x. So x to the second power, we want to get rid of that exponent. So how do you get rid of an exponent of 2? You square root both sides. And what do we always apply when we take the square root of both sides? Plus or minus. And so now you get x is equal to plus or minus 1, x is equal to plus or minus 2. Now, I want to talk about something, but first of all, I want to ask, did the process that we just went through, applying a u, we call it a u substitution, does the process of making that substitution, creating a quadratic equation, solving that quadratic equation, reapplying our substitution, solving then the resulting equation to get x, is that, were you able to follow that? Did it make sense?
Yes, sir.
Alright, now what I want to talk about is why is it quadratic in type? Why? Because when it comes to the exam, I'm going to give you a bunch of problems. I'm just going to say solve. It's not going to tell you what kind of equation it is. It's not going to say solve the quadratic equation, solve the absolute value equation, solve the rational equation. It's just going to say solve. So you have to be able to determine what type of equation you're looking at, and then from there make a decision of how you're going to solve it. So why is this quadratic in type? Well, not maybe recall, but look at ax squared plus bx plus c. That's a quadratic equation, something that we're very familiar with. And I want us to note the following. note that x right there, if I square it, I get x squared. Okay, alright, I see that, Mr. Clopton. Yeah, that makes sense, duh. X squared makes x squared. The same pattern still holds for this problem. Take a look at this equation. If I have x to the fourth minus a 5x squared plus 4 equal to 0, if I take that x squared and I square it, we get x to the fourth. That's part of what makes it quadratic in type. You have this relationship between your variables where if you square the middle variable, you get the first variable and its exponent, and you also have, I should also emphasize that we always have a constant. Here is our constant. So, in problems 15 through 18, you have these various types of quadratic equations. I'm going to make another quadratic type equation using these same coefficients. Check this out. Let's do a different color. So, what if I change it to x minus 5x to the 1/2 plus 4? Is that quadratic in type? So pretend like I gave you this question on the exam. How would you solve this question? Well, I would take a note and I would say, what happens if I take x to the 1/2 and I square it? That becomes x to the 1/2 times 2 over 1, which is x to the 1, which is that variable. And I have a constant. So, I would do this test. If I take the middle term and I square it, do I get the first term? Yes. Do I have a constant? So all of this is evidence that what we have is a quadratic type equation. So how would I solve this? I would go through and say, well, let's let u be equal to x to the 1/2. Then u squared is going to be x. Then I have u squared minus 5u plus 4 equals 0, which is the exact same thing that I had up here. So you're going to get u is equal to 4 and u is equal to 1, which then you're going to say x to the 1/2 is equal to 4 and x to the 1/2 is equal to 1. And then you're going to solve these two guys. How do you solve those? I would raise both sides to the second power. And you get the following. X is equal to 16 and x is equal to 1. There are your two solutions to this quadratic type equation. It was made using the same numbers as you saw on 15. Same numbers, I just changed the variables to fit this quadratic type form. Alright, there I took a little time to explain what makes it quadratic in type. Does it make sense? What makes something quadratic in type? Do we want to look at some more of these problems, or does it make sense? What makes a quadratic type equation? Yes? No? Maybe so? Makes sense? Okay. We can do some more, but maybe we have some other questions that we want to tackle. while I'm, go ahead, go ahead.
Can you do number 18?
Sure. Guess what? It's quadratic in type. It's quadratic in type. Why? Well, if you take the variable, notice that you have this x minus 5 and an x minus 5 here. If you take that and you square it, guess what you get? You get x minus 5 quantity squared, which is exactly what we have right there. So again, you can use a U substitution. So what I'm doing is I'm simplifying this problem. I'm making it less complex by using a substitution to represent this x minus 5 and this x minus 5 squared. If I let x minus 5 be equal to u, then this x minus 5 squared is u squared. So now you have u squared minus 4u minus 21 is equal to 0. Factor. So factors of 21 that make a negative 4, factors of negative 21 that make negative 4. How about a negative 7 and a positive 3? So that means that u is equal to 7, u is equal to negative 3. So what is u? U is x minus 5. Now I have it in terms of x. So how do we solve for x? I would add 5 to both sides. We get x is equal to 12. We get x is equal to negative 2. That's how I would tackle that problem. There's another way to look at problem number 18. Alright, so before I look at the other approach to it, does it make sense? I'm sorry, what?
The x is equal to positive.
Positive 2, sorry. Does it make sense? Yes, no, maybe so? Yeah. Another way to tackle the exact same problem. If you wanted to, you could expand it. So you have x minus 5 times itself. Distribute the negative 4, so that's minus 4x plus 20 minus 21. FOIL x squared, you're going to get a minus 10x plus 25 minus 4x. 20 minus 21 is a negative 1. Then you get x squared. 10x, negative 10x minus 4x is a negative 14x. 25 minus 1 is a 24. And then I go through and factor and solve. And you're going to get the exact same thing after you do all this work. You're going to get the exact same thing that you have right up there. The point of these problems, again 15 through 18, is to see how you can solve problems using a substitution technique. We're trying to exercise using a substitution technique. Okay, what else can we look at?
Can we do 10 on assignment 7?
10 on assignment 7, sure. Problem number 10 on assignment 7, we have negative 3 is less than or equal to a 2/3 x minus 5 is less than or equal to a negative 1. So we want to do 3 things. We want to solve, we want to graph, and we want our solution in what's called interval notation. Alright, so this is what's called a compound inequality. It's an inequality statement where you have 2 inequality symbols. Your variable is going to be sandwiched there in the middle between the two inequality symbols, and we're going to treat this like any other equation where we want to start isolating x, and the idea is what we do in the middle to get x by itself is we're going to do on either side of the inequality symbol. So if I'm just looking at this expression 2/3 x minus 5, and I want to start getting x by itself, I would start off by adding 5. What you do in the middle, we do on the other sides of the inequality. So think of this inequality, these inequality symbols, they're not equal signs, but they're acting like, this is the other side of the expression, and this is the other side of the expression. So you got to be thinking about what you do in the middle, you have to do on both sides. So we are end up with a positive 2 is less than or equal to 2/3 x is less than or equal to a positive 4. So the next thing that we want to do is we want to get rid of the 2/3 x that is multiplying, or the 2/3 that's multiplying the x. And what we're going to employ here is to get rid of this 2/3, I'm just going to multiply both sides by the reciprocal. The reason that we multiply through by reciprocal is, alright, so two ways to look at it. Look at this, the 3's cancel out, the 2's cancel out. Or you could say 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1. Coefficient of 1 in front of your x, that's what we want. So let's do some multiplying. 3 times 2 is 6 over 2 is less than or equal to x is less than or equal to 4 times 3 is 12 over 2. We can further simplify. 3 is less than or equal to x is less than or equal to 6. Alright, so before we move on, There we have just solved. Does it make sense how we just solved this? Any questions on how we solved this? So the person that asked this question, does it make sense?
Yes, sir.
So now you want to do two things. Graph the solution and then write the answer in interval notation. Sometimes people say solve, interval notation, then graph, but I like graphing first. It just makes more sense to me. So the only numbers I care about are 3 and 6. I don't care about 0. I don't care about the 4, the 5. I don't care about anything else. I just care about the 3 and the 6. X is sandwiched in between those. And I'm not going to get too picky about this. For our purposes, you can just use a solid circle. Solid circles are for the or equal to part. So there's your graph, and this translates to our interval notation. Solid circles are going to be represented with brackets. Sometimes I used to be really hard-nosed about this, but then I just gave up. I used to say, all right, let's get away from the solid circles and the open circles, and we're going to just use the brackets. I quit being such a hard-nose about that a couple of years ago. So you might see some textbooks or answer keys represented like this, where they use the brackets instead of circles. And the brackets are just a way to say that we include the 3 and the 6 in our solution. And again, this is our, not a parenthesis, but a bracket. This is our interval notation. So just a little side note. If we had, maybe for example, 3 less than or equal to x less than 6, this would translate into the graph. Again, we shade in the middle. We would use a solid circle around 3, but we would use an open circle around 6. The interval notation, we would have a bracket around 3, parenthesis around the 6. Make sense? Anything else does that make sense? Yes? Okay. What else can we look at?
Number 16 on assignment 6.
16 on assignment 6. This here is another quadratic type equation. So, let's pretend that this is a question that I throw up on a quiz or an exam, and the only directions say to solve. There's no indication as to what kind of equation that we are dealing with. So this is where you got to start looking for patterns. Here's what I notice. One, there's 3 terms. That's a little clue. 1, 2, 3 terms. Alright, so there's 3 terms. 2, there's a constant. That minus 6 is a constant. And 3, if I take x to the 1/3 and I square it, alright, this is where you got to really have a good grasp of your exponent rules. What do we do with x to the 1/3 raised to the 2nd power? That's equivalent to x to the 1/3 times a 2/1, which is x now to the 2/3. So if you take the middle term, the variable of the middle term, and its exponent, if you square this, you get the variable and its exponent of the first term. All of these are clues that lead us to the conclusion that this is a quadratic type equation. So this is where you gotta start putting your thinking cap on. You gotta start analyzing the equation, and you gotta start looking at it, and you gotta start making some thoughts about the equation. 3 terms, constant. There's a relationship between the middle term and the first term. All of these clues lead us to the conclusion that it's quadratic in type. So what do we do with a quadratic in type equation? We use a substitution. Let u be equal to x to the 1/3, then u squared becomes x to the 2/3. With me so far? To the person that asked the question, you with me so far?
Yes, sir.
So, this becomes u squared minus u minus 6 equals 0. We're going to factor. Oh, what are the factors of -6 that make a -1? How about a +2 and a -3? So you're going to set each of these equal to 0, which then means that u is equal to -2 and u is equal to +3. Great. But I don't want to know what u is. I want to know what x is. So we're going to apply our substitution to what we have right here. We can now say that x to the 1/3 is equal to -2, and x to the 1/3 is equal to 3. So we took this quadratic type equation, we made a substitution so that we had a quadratic equation, we solved the quadratic equation, we reapplied our substitution, and now what we have is we have a different type of equation to solve. The hurdle here is, how do we get rid of the exponent of 1/3? Well, we just cube both sides. X to the 1/3 cubed just becomes x. Negative 2 to the third power is the negative 8. X to the 1/3 raised to the third power is x. 3 to the third power is 27. Did you follow? Does it make sense? Yes? No? Maybe so? Do I need to re-explain something?
No, sir, I'm good.
Okay. Does that help?
Yes, sir.
Alright. So, again, I just want to take this opportunity to express how many different ways we could use this. What if I had x to the 4/5 minus x to the 2/5 minus 6? That's interesting. Take a note. If you take x to the 2/5 and you square it, that's now x to the 2/5 times 2 over 1, which is equal to x to the 4/5. So, y'all answer this question for me. Is this a quadratic n-type equation? Yes or no? Is this quadratic in type? Thumbs up, thumbs down. Yes or no? It is. So, if I let u be equal to x to the 2/5, u squared is going to be x to the 4/5. You get u squared minus u minus 6 equals 0. We already know what happens here. Do a little bit of work, and you get u is equal to negative 2, and you get u is equal to 3. Then we can say, since u is equal to x to the 2/5, x to the 2/5 is equal to negative 2. X to the 2/5 is equal to 3. So here's how we'd solve this problem. Five over 2. 5 over 2 raised to the 5 over 2 raised to the 5 over 2. I'm running out of room, so we're just going to have to squeeze it in over here. Yet x is equal to, so 2 to the 5th is going to be a 32. Then you want to do the square root of 32. We don't have time to go over all of this. I probably wouldn't do a problem like this, but you would have plus or minus. I would just rewrite it as 2 to the 5 halves, and then x is equal to plus or minus 3 to the 5 halves. And the reason that you include the plus or minus is because you're taking a square root because you have the index of 2 right there. Alright, just another example of how I can create a quadratic type equation based on something like this. Man, my voice is killing me. Alright, what else can we look at? We have 3 minutes left. Anything we can look at? Anything from assignment 7? All right.
Your conference is scheduled to end in 2 minutes.
Thank you, lady, for letting us know. All right. Here's the plan for Friday. We will continue to, so we spent, most of the day was spent answering your remaining questions over assignment 6. We will have a quiz on Friday. We will begin class with addressing any questions over assignment 7. Your quiz on Friday can include any material up through assignment 6. So, if I recall, the last quiz that we took, I think the farthest that we got to was assignment 4. I think the last thing on the quiz was a dividing by a complex number. So what you can expect for Friday's quiz would be problems from assignment 5, solving quadratic equations, and then assignment 6, solving the other types of equations. We'll have a quiz on Friday, much like the previous Fridays. It'll be in the last 20-25 minutes of class. So make sure that you're ready for that quiz. Next week is our exam week. Monday we review. There is the unit review for this section. Be looking at that
Your
review.
conference is now over. Goodbye.
We'll answer those questions on Monday, exam on Wednesday and Friday of next week. Have a good day. Bye.